Welcome to this presentation on C++ arrays and lists. We're going to start out looking at some of the basics of C++, how to create an application in Visual Studio, and then we're going to move on to how to convert a C++ program that uses a standard array into one that uses a dynamic array or list class, and this is a good first step towards learning data structures. Before we start looking at the code, let's take a look at Visual Studio in general. Where do you get a compiler that's required to build and run programs? There are a lot of different options, different compilers, different development environments that you can use to create C++ programs. In this course, we're going to look at how to use Microsoft's Visual Studio, which is a really good one. If you go to just do a search for Visual Studio, you'll end up at a page something like this. And this is the one you normally want to use. If you use the Visual Studio Community Edition, it's free, it doesn't cost you anything. You may be required to register with Microsoft, so create a Microsoft Drive account or something like that. But it's free, it doesn't cost you anything, and then you can have this, what they call Community Edition, as long as you want. That's what I'll be using in this presentation. And when you start it up, it may start up looking something like this. So there's some other options here, but the Visual Studio Community Edition is what I'll be using. Another option is some of you may already have a previous version, so you may have Visual Studio 2013, 2017. There have been a lot of versions over the years. And for the work that we do in this class, it really won't make much difference. We'll look at a few features that come from the newer C++ 11 standard or the C++ 2014 standard. We may look at just a couple of features that come from those, and if you have an older version of the Visual Studio, those features may not compile, but you can rewrite the code to not use those features, so it's not a huge deal. You can also get Visual Studio in our DeVry's Virtual Lab or iLab, so that may be another option for you. So this is the website where you would get Visual Studio for Microsoft, and then when you run it, it may look like this. So let's see how to create a program in our environment. In our course this session, we'll be creating what we call C++ console applications, which means the output of the program, instead of being a Windows program with menus and things like that, will be just a little command prompt that just has text output. So to do that in Visual Studio, we will create a new project, and it may look a little bit different in some of the older versions. You may need to go to the File menu and say File, New Project. So we can create a new project here, or if we continue without the code, you may see something like this, where you go File, New Project, and then from here we want to create a C++ console application. When you hit the next screen, this is really important step that some students may overlook. It's important when you create the project that you know where the project is located. So in this case, it has some default location that I don't normally use, so I'm going to pick a new location, and I happen to have a folder for this particular class, CEIS 295, and I'll make another folder for that maybe, or actually the project will make another folder for that, so we'll just use this. And then I can call it console application 1 or 2 or array list or whatever the name you want to call your project. And there's this option here where you can have the solution and the project files in the same folder or the same directory. And in some of the older versions, the default was to have a top-level solution folder and then a child folder under that for the project. And it's a little more complicated than what we need. You can do it either way. There's no problem with doing it either way, but it's a little bit simpler, I think, to have the solution and the project in the same directory. And so if this is checked, then you don't have to come up with a separate solution name. So then the next step is to create this project there. And we made a mistake already. So one of the problems that we have with Visual Studio is that it creates code for you. So it automatically created some code for us, and I wanted an empty project. So let's see if I can do this again. So I'm going to close this solution and show you where it was made. So this solution was made here in this CEIS. So it was made in this new folder, array list, and it automatically created some code for us, which I didn't want. I wanted to make an empty project. So I'm going to delete that and go back to Visual Studio and file new project and a console application. Put it in the CEIS 295 folder. And normally there's supposed to be an option here for creating an empty project. I'm surprised about that. So this is a little bit different behavior in this 2019 version that I've seen in the past. In the past, in other versions, I've seen the capability to create what we call an empty project. So you get a window like this that comes up as part of the project creation, and you can create a console empty project. In 2019, it looks like it's a little bit different. I'm surprised. Okay, well, what we'll do then is we'll just use this console application 1 CPP as a starting point, and it's got some directions in there for you, so it's really not a bad thing, I guess. And I usually like to put the name here. So it includes an IO stream and a simple hello world, and it uses this namespace modifier here. And if you don't want to put the standard : in front of everything, you can use this using namespace standard, which says we want to use items out of the standard namespace, so we don't have to prefix cout and other things with standard. To build and run the program, you go up to the build menu and build solution, and then in an output window here you should see some messages. And it'll tell you succeeded if there's no errors, or if there are, it'll give you error messages and line numbers, and you can try to figure out what they are and try to fix the errors. And then to run it, you can go up to the debug menu and either start with debugging if you want to debug it, or start without debugging. And you see we get a little hello world on the output. So let's look at creating an array. As you recall from previous programming classes, a standard array may look like this. And you can use a loop to fill that array with some random values maybe. So if the random number generator in C++ gives you a random number between 0 and 32,000 something, and if we do a modulus by 10, then we'll get random numbers between 0 and 9. And then sometime later, we want to print this out. We can reuse the same loop and just print out the contents of the list. So if we build and run this, we get 5 random numbers. One interesting thing is, notice the random numbers we got here, 17409. If I run this again, I get the same series of random numbers. And this is because the random number generator creates values based on a seed, and the default seed hasn't been changed. So I'll have to look into changing the seed of the random number generator, and we usually do that by giving the seed as the system time on the computer, and that'll be in seconds or milliseconds or something like that, and that'll be somewhat random. But for now, this is fine. We'll just use the same random numbers over again. So the problem with this basic array is that it's static in terms of its size. So when the program is compiled, a sub array with a dimension of 5 says we only have 5 slots or 5 locations in our array. The problem with that is, as soon as you compile the program and deliver it to your customer, they're going to want 10 numbers or 100 numbers or 1,000 numbers. So we need to allow for some dynamic array capability. We'll come back to this header versus implementation in just a minute in the presentation. So how do we do that? Well, one thing we'll do is we'll create a class for something called an array list. And just for now, we'll make everything public to keep things simple. And we'll create a pointer to the data. So we'll create a pointer to integer data. And we can allocate, or, well, in addition to having a pointer to the data, we can store the current size of the list as well as the capacity. So we may have the list have a capacity or a number of slots reserved to store 100 things, but currently we may only be using 60 or so. So in the constructor for the array list, we may want to give it a default size. So we can say pdata equals a new array of integers, some default capacity. And we could say the capacity may be 10 things or 20 things or whatever. So now we have enough space for 10 items in our list, but the current size of the list is 0 because we haven't added anything. So then the other thing we might want to do is to be able to add an item to the list. And so our ArrayList class is going to have a method where we can add an item to the list. So when we do this, we want to take the data, which is a pointer to a collection of integers, and find out where to put it and put that item in the list. Now the question is where to put it, and this is kind of an interesting thing. The current size not only tells us how many things are in the list, but it also just so happens to tell us the location of the next spot to put it in the list. So when the current size is 0, that's the place to put it in the list. If the current size were 5, that would be it means we would be using slots 0, 1, 2, 3, 4, and so slot 5 would be the next place to put the new item. And then of course after we've put an item into the list, we want to increment the current size. We've added another item to the list. We might want to print or display the list, and that code would look very similar to this code here. But instead of a sub I, our array is p data. So now, instead of using my integer class, I can create an array list and I can add random values to that array list and then print them out with the display method. So we are declaring a class called ArrayList, and it has a pointer to a block of data that's going to contain a collection of integers. It has a current size and a capacity, and in the constructor, the default constructor, which is going to get called when we declare the ArrayList here, we just set that capacity to some default value, allocate memory for the data, and then set the current size to 0 because there's nothing that's been added to the list. We can add an item to the list, put it at a particular location, which coincidentally happens to be the same index as the value of current size, and increment current size. And then we can display the list by looping from 0 to not 5, but 0 to current size, and displaying the items in the list. So here we declare a list, add some random values to it, and then display a list on the output. So let's see if this will build. So it succeeded, and then if we run it, we get the same 5 values in the list. Now, what if we wanted to add more values? So I want to add the value of 28. Maybe I want to add a value of 32, 45, and so on. So now I should have a total of 8 things in the list. Alright, that's not a problem. But we are going to run into a problem if we try to add, say, 5 more things to the list. And the reason this is going to cause a problem is we put 5 things here, we put 5 things here, we put 3 things here. That's a total of 13 items in the list, but we gave our list a capacity of 10. So this is going to end up being a problem. If we try to run this, we get an error message something happened, it's not working properly. And what happened is we have this, what a common problem with arrays and even dynamic arrays like this is what we call the out of bounds problem. So we tried to access or store information that was outside the bounds of our list. Our list had 10 slots, and we tried to put things in slot 11 and 12 and so on. So that's a problem. So what we want to do is to make our list dynamic where it can grow if needed. And so to do that, we can add a function maybe called resize or something. And what we end up doing is creating another list that's this new size, and then copying the information from the old list into the new list, and then freeing up the memory or deallocating the old list. So to do that, we create a temporary integer pointer that is equal to the current list or the old list. And then just as we did in the constructor, we set the capacity and allocate data, but this time not 10, but whatever the new size needs to be. We allocate that data. Now we're going to do a loop that's very similar to the display loop, but we're going to copy, instead of printing, we're going to copy data from the old list, which was stored in ptemp, to the new list, which was allocated here with the new size. And we only need to go from 0 to the current size of the list. We only need to copy the number of things that we're using. When we're done with that, we can free up the data for the old list by saying delete. Ptemp is the pointer that stores, that's pointing to the old list, and that's the proper syntax for for deallocating a dynamic array. Sorry, it's like this. Yeah, use delete with the square brackets afterwards to deallocate memory that's been reserved for a dynamic array. So this is the resize method, but it doesn't get called anywhere. What we need to do in add is to check to see if the list is full. And the way we can do that is if the current size is equal to the capacity. So once the current size gets to be equal to the capacity, that means that the list is full. If the list is not full, well, we can just keep adding things as we did normally. So what do we do if the list is full? Well, we need to resize it. So we're going to resize the list, and what should the new size be? And this is the resize policy that varies depending on the type of data structure that you're doing. One common policy is that every time you do a resize, double the size, double the capacity. So we're going to resize it to twice the existing capacity. And I guess once we do that, we don't really need the else here. So if the list is full, we resize it and then add. If the list is not full, we skip this part and add the item in anyway. So this should fix our out of bounds problem, because when we try to add in more than what the original capacity will hold, then the list will be resized. So let's give this a try. We go to the build menu, or sorry, build and compile it and see if we have any errors. It says it succeeded, and then we go to run it, and now you see we've got 13 items displayed from our list. One of the things you're going to see in the lab that's a little bit different is that The labs often use more than a single file. So they will use a header file like array or ArrayList.h, and that declares the class and its data members and its methods, and then they use a separate implementation file like array.cpp, and that has the definitions of the classes methods, and then a separate CPP file that uses the array class, and that usually has main in it. So this is a common programming practice to take large projects and break them up into pieces in different files, and we can do the same thing in our program. So in our program here, we have just a single console application.cpp file, but we may want to break it up into different parts. So what we may want to do is add a new item to the header file section, and we want to make sure that it's much more useful if it's in the same folder as the other code. And this is going to be a header file, and we're going to call it ArrayList.h, and we get an empty file. And I like to put the name of the file in a comment right above. It automatically puts this pragma once in here, and the reason for that is if the C++ compiler sees a declaration for something like a class more than once, it will treat that as an error, that you're trying to define the same thing more than once, even though it's the exact same definition. It seems silly, but that's the way C++ works. So if your implementation file, ArrayList.cpp, includes ArrayList.h, then the compiler sees the definition for this ArrayList class. If your driver program that has main also includes ArrayList.h, then it'll see the declaration for that ArrayList class a second time and likely throw an error message. So that's what this pragma once does, is says only include this header file one time, even though it may actually be included more than once. So then what we can do then is take the ArrayList class and copy it to, or actually cut it and move it to the ArrayList.cpp. And then when we do that, it doesn't know what cout is, and that's okay because we're actually going to move cout, we're going to move the code for these functions to a separate implementation file or C++ file. So the step to do that is to create a new source file, and this is going to be a CPP, and I usually use the same name as the header file, but ArrayList.cpp, but with the C++ extension, and again in the same location as the rest of our project. And then in here, the first thing you want to do is to include the ArrayList.h that has our definition for the class in it. Then from here, what we're going to do is take all the functions, all the methods, and move them to the C++ file. And every one of them we have to prefix with the name of the class and the scope resolution operator. So we prefix the name of every one of those with the name of the class and that's scope resolution operator. And then in order to be able to use cout, we also need the include and using namespace standard. So then in the header file, we can change these methods so that they don't have the code, they're just prototypes. So we do that like this. We just include the the return type, the name, the parameter list, and a semicolon. And this is just an organizational thing that can be useful for larger programs. We take larger programs and break them up into separate header and implementation files. And in the header file, we usually have class declarations, function declarations or prototypes, and then within the class we include the data members and the method declarations or the method prototypes. And then in the implementation file for that particular class or module, we include the header file, any other headers and namespaces that we need, and then actually define those methods. So now in the main program, sometimes they call this a driver program, we need to include the header file that defines ArrayList. And in this case, we're using an include with double quotes instead of square brackets. And that tells the compiler, instead of looking in the system folder for standard includes like IOStream and so on, look in the project folder for include files or header files that we've created ourselves. So now when we build this, you actually see that you get separate compilation steps for ArrayList CPP and console application CPP. So it's compiling those C++ files separately, and then it succeeded, so we didn't get error messages, and if we run it, we get the same, pretty much the same output. So this is what we're talking about here in the presentation about creating separate header and implementation files. And you can see the header file here. In this presentation, instead of calling it resize, they called it increase capacity, and they called it CArray instead of ArrayList. And instead of using the pragma once, they used here a conditional compilation directive. So this is another way of preventing this array class from being included or seen twice in a project. You'd use a conditional compilation directive which says if in def, if not defined some symbol, and the symbol that's often used is the name of the header file with an underscore instead of a period. If that symbol is not defined, then define it, and that includes everything here, and then at the end have an end if, which ends that conditional compilation block. So the first time this is included, that symbol is not defined. No symbols are defined maybe. And so it's defined to the preprocessor, so the next time it's included, it will be defined, so the if end def will be false and it'll skip all that inclusion. We accomplished pretty much the same thing with that pragma once directive, which may be a little simpler. So notice here in a project we've got separate header and source files, and some of the code here. In this particular presentation there's a slight bug here where our add method, if the size was equal to capacity, if it was full, they increased the capacity to a constant 256. And if you think about it, that's really kind of a bug, because what happens if you want to put more than 256 things in there? That won't work properly. So this slide here really has a little bit of a bug here in the add. And of course it's nice to put more comments in the code above what each function does, and then a few comments within the functions that help remind the programmer and other programmers what those functions do. Here's main.cpp. In this case they created two different lists, a list of evens and odds. So let's see if we can do that easily. We'll modify this to create an even list. odd list. And here we'll put in a series of even numbers. And here we can put in a series of odd numbers. Display the even list, and then display the odd list, or in the other order, it doesn't matter. So now we can have two different lists with different names in them. And we scroll up here, we see that the even list 0, 2, 4, 6, 8, 10, and then the odd list 1, 3, 5, 7, 9, and so on. And they're different sizes, and both of those lists started out with a default size of 10, but they grew in capacity to accommodate whatever size list we needed. So this slide here just shows building. Let's actually look at an error message. I don't know that we've seen too many errors here, so let's create an error. So I'll go up to maybe the header file and forget a semicolon. And now if we try to build this, you see that we get an error message, and it said syntax error, void should be preceded by a semicolon, and that may be confusing. So it's not always easy, and it looks like there's two errors, but the reason for that is because it's being included twice, I think. If we double click on it, it does try to tell us that this line is an error, but the problem is it's not this line that's the error, it's the line above. And this is not an uncommon thing when you're looking to try to find where errors are. Sometimes the compiler will tell you an error is on a particular line, and it's not really on that line, it's on the line above in this case, or maybe several lines above. In this case, the error message is here, missing the semicolon. We'll go to the implementation file and maybe put a mistake in here somewhere. And what happens if we forget this part? Then we get that p data is an undeclared identifier, and that can be confusing because you say, well, this is a member of the class, and definitely p data is in the class. The problem is we didn't tell it resize was a member of the ArrayList class, so it's assuming that resize is just a regular function, and there is no definition of p data within this regular function resize. So to fix that, we have to use the name of the class and the scope resolution operator to say, I'm defining a function resize that's a member of the ArrayList class. So we've talked a little bit about the fact that arrays have a couple of properties. One is they're homogeneous, meaning that all the elements are the same type. They all have the same data type. In this case, we used integers. And they're contiguous. All the elements are adjacent in memory. That's a useful thing sometimes for performance. But the real issue here is that they're a fixed size. Okay? So all the elements or the array, after it's been compiled, has a fixed size. And that's very often not useful or not what you need. You need an array that can change size. So we create a dynamic array with a new operator, and then you have to resize the list by copying from the previous list to the new list and then allocate the new list. And there's a potential for memory leaks. Let's talk about that. What is a memory leak? Take a look at the code here where we resize the list. We allocate a new block of memory, copy the data from the old block of memory to the new block of memory, and delete the old block of memory. Well, what were to happen if we did not delete the old block of memory? What would happen then is that bit of memory would still be reserved, and the new memory would be reserved and stored in our PData data member. And the old block of memory is just in this temporary variable that's local to this function. So once we exit the resize function, we would no longer have a pointer or an address to that old block of memory, and then there's no way to delete it after that. And that's referred to as a memory leak. And if we were to call resize over and over and over again in a loop, then we'd have a problem where we'd have these old blocks of memory that are still reserved and there's not being deleted, and there's no way for us to access them or free them up. And that's referred to as a memory leak. And if that happens enough, you'll eventually consume all the available memory that your program can access, and the performance of your program will go way down, and eventually it'll crash. It's a good chance it'll crash the system. So this memory leak problem can be pretty serious, and so you need to be very careful that you allocate memory and deallocate memory when it's no longer needed, especially the deallocation part. And we'll see more examples of that a little bit later on in the course. All right, the last thing we want to look at is the standard template library vector class. So it turns out some of these data structures, like a dynamic array, have already been created for us in what we call the standard template library, STL library. In this case, they call it vector. And so over here I have some documentation from a great website called cplus.com, and I strongly encourage you to go through this, especially the tutorial section. It'd be a very useful thing for you to go through the first half a dozen or more tutorial section. And so in addition to documentation, they've got tutorials. They also have a forum where people have asked questions, and of course they have documentation. And really one of the really nice things, let me see if I can show you one here. One of the really nice things in cplus.com is they've got a lot of sample code, so you can look at the vector pushback function, and it tells you what it does and the return value, but it also has sample code, and a lot of times it shows the output, or you could just copy and paste this sample code into some of your project and run it and see what it does and play around with it. So it's really nice website. And also the tutorial section on the C++ language, if you haven't been through this before, really recommend you go through the first, I don't know, maybe up to classes and classes 2. Be a really good review of C++, or if you're maybe a little bit weak with C++, it'd be really good to help you learn it better to go through the first, I don't know, 10 or so sections up to classes and classes 2 probably. So let me show you an example of how we can do something similar with a vector class that we do with the array list. So in our code in main, instead of having an odd list that's array list, maybe we'll make it a vector of integer. So that can be a useful thing. And we get error messages here because the compiler doesn't know what a vector is until we tell it to include the vector header file. And the documentation tells us this. Well, it doesn't tell us so much here, but in the examples, it shows you how they're including the vector header file. So for odd list now, because it's a vector and not an array list, its functions will be a little bit different. Instead of add, they call the function to put a value in the list pushback. And then there's no display function, but instead we can loop through the values of the list and print them out ourselves. So, and there's a few different ways to do that. One is that you can use a loop from 0 to the size of the odd list. So the odd list has a size function which tells you how many things are in it. And you can print out odd list sub I should give us the same output. We got the even list here and then the odd list here. The other thing that we can do is there's different ways of accessing values in the list. So here we're accessing it as an array. We're accessing the value in the vector as an array. Another thing that you can do is with a thing called an iterator. So we can create a vector int iterator, and that can start at the beginning of the list and keep going until we've reached the end of the list and increment the iterator. And an iterator is an object that refers to an item in the list. In this case, it's referring to the beginning of the list, keep looping until it doesn't refer to the end of the list, and we increment the iterator just like we would an integer. But now we can dereference the iterator as if it were a pointer and print out its value. So this does the same thing, printing out the contents of the odd list. It's just another way of accessing values within a list. So in this particular technique, we're no longer using an index into the list, we're using an iterator. In C++ 11, I think it was, they added this auto capability where if you can't remember what this is, or if you want to have your code, you may use a different type of container, or instead of a vector of integer, you may have a vector of double. It might be easier to use the auto keyword. And so the auto keyword says, try to automatically figure out what the data type of this IT thing is based on what you're assigning it. And this will do the same thing, just maybe makes the code just a little bit simpler, a little bit easier to manage and maintain. And then another possibility is use what they call a range-based for loop, which again is part of the newer C++ standard. So if you have an older version of the compiler, you may not be able to do this. But with a ranged loop, you can write, again, auto val in odd list and print out the value. So this particular version of the loop, I think they call it a range-based loop, where the value variable is going to take on each value in odd list in order from the first to the last, and then we can just use it as any other variable and print it out. The downside of this particular version of the loop is that you don't get access to the index, which in some cases you may need. So in the loops with the iterators and in the range-based loops, you don't get the index. You're not using the index, and in some cases you actually may need that. So this is a review of how to use the STL vector capability. And again, here's some examples of creating a vector of integer, putting in some values, printing out the integer with an index-based loop, printing out the integer with an iterator, printing out the list with an iterator using the auto keyword, and then printing out a range-based loop. Noticed here that we used auto reference value, and because in this particular case value was a reference variable, that means you could actually assign something to it and change one of the values in the list if you wanted to do that. So that concludes the presentation here on arrays and dynamic arrays. Let me know if you have any questions.